I think that our most important discovery has been the use of electrical stimulation to provide people with vision impairment the ability to be able to get some sense of vision back. It's not vision as you and I would know it, but it does provide these people with an ability to be able to regain their independence, to move around in their environment, to avoid obstacles, and ultimately through that to improve their quality of life. I've always been interested in the brain, and the opportunity to work with Professor Graham Clark at the Bionic Ear Institute was a fantastic one, to come to Melbourne to work on the cochlear implant and then to develop that technology further with the work that we've done on the bionic eye. We were able to use the same sorts of technology, so the same materials that they use, the same sorts of electrical stimulation, and to be able to translate that into how it could be used in the retina. And we've been able to take that technology to the next level, and we're seeing that now being translated into a commercial device that we hope will have great impact both here in Victoria and internationally. The very first sort of switch-on moment for the first patient was really quite remarkable. We had done all the background work and we were fairly sure that the device would work, but until we could actually see it functioning in a patient, you never quite know how it's going to function. And that was a fantastic moment to see the patient sort of light up and be able to explain to us what she was seeing. Here in Victoria, we've got a really unique opportunity because we have such depth of expertise in both engineering and in medicine. And it's also one of the great centres of people working together where in fact it's easy for us to collaborate with our clinical partners, and the way in which that collaboration works has really enabled this technology to really take off here in a way that perhaps wouldn't have happened elsewhere. We developed the technique for being able to implant the device with our colleagues here at the Royal Victorian Eye and Ear Hospital in a way that is able to be done surgically within a very short period of time and that protects the retina from ever coming in contact with the implant itself. We want this technology to be of use for patients, and the only way that that can happen is if there is a company that will carry that through and make that a commercial product. So we had a focus upon making sure that we had all the patents for the technologies that were developed were protected and that this could form part of the basis of a company here in Australia. In addition to blindness, our research really has application in other areas such as movement disorders, conditions like Parkinson's disease, and also conditions like epilepsy, where being able to use electrical stimulation to intervene can really have a dramatic effect upon people's quality of life. This area of research in medical bionics really has an enormous future. We're only really starting to tap into that now. The cochlear implant represented the first generation device. We'd see the bionic eyes, perhaps the second. And now from that technology, we're seeing a whole range of possible applications. And I think we really just stand at the very threshold of all of the different areas in which this technology can be applied in the future. I'm Professor Anthony Neville Burkitt, the Chair of Biosignals and Biosystems in the Melbourne School of Engineering at the University of Melbourne. And I'm honoured to receive the 2019 Victoria Prize for Science and Innovation in the Physical Sciences.